Hello, welcome to the Spirit of Apollo. I'm your host, Mark Lesmeister. Today we're going to talk about the different mission profiles that NASA considered in order to land astronauts on the moon. Two of these involve something that was probably the first French word I ever learned, rendezvous. I'm going to attempt to explain the different methods using some simplified models that I made with Legos. This first model is meant to represent the direct ascent approach. A rocket takes off from the Earth. It's got to be a huge rocket because it's got a lot of mass. It has to get into Earth orbit. Those stages fall away, and then these stages go to the moon, landing on the moon, and then this stage takes off from the moon and goes back to the Earth. Now, you need a huge rocket to do this because you have a lot of mass that you have to get not only off the Earth, but to the moon, and then landing on the moon, and then, and this is the hard part, taking off from the moon with all that mass, and then getting it back to the Earth. Now, the advantage of the direct ascent approach is that it was very simple. There was no orbital rendezvous required. Remember, this is being done in the early 1960s, and NASA had not even done an orbital rendezvous yet. But you need a big rocket, an even bigger rocket than the Saturn V. NASA actually did design work on rockets larger than Saturn V, such as the Nova series. Now, once President Kennedy announced our goal of landing on the moon before the decade was out, this approach became a lot less feasible. The Nova rocket wasn't anywhere close to being ready. So NASA started to look at approaches that would involve the far closer to being ready rocket, the Saturn V. Another approach considered by NASA was the Earth orbit rendezvous, in which two or more Saturn V style rockets would take off from the Earth, either simultaneously or one after the other. And then, after shedding their lower stages, it would orbit the Earth, and then some assembly would have to be done. You would assemble the rocket that's actually going to go to the moon in Earth orbit. That rocket would then go to the moon, land on the moon, and then the upper stage would take off from the moon and come back to the Earth, where it would either land or splash down. The advantage of this approach is that it used a rocket that was a lot closer to being finished, the Saturn V. The disadvantage, of course, is that you got two rockets, that's twice the complications. Also, you do require a rendezvous, although it's in Earth orbit, so supposedly it should be simpler. The approach that ultimately won out at NASA was considered to be the riskiest approach at first. It was called the Lunar orbit rendezvous. In this approach, you have a single Saturn V taking off from the Earth, the lower stage is falling off, and then the upper stage sending the astronauts on their way to the moon. Once the astronauts are safely on their way to the moon, the command and service module can separate from the rest of the rocket, turn around, and extract the lunar module from the rocket. The rest of the rocket can be discarded then. But once the astronauts are safely in orbit around the moon, two of the astronauts climb out of the command module and into the lunar module, and then they separate. The command module remains in orbit around the moon, while the lunar module lands on the moon. The astronauts get out of the lunar module, do their explorations. Once they're done, they climb back into the lunar module, the lower part of which is left behind. That's called the descent stage. The upper part takes off, and in a maneuver called a lunar orbit rendezvous, joins back up with the command and service module. The astronauts go out of the lunar module, get back into the command module, and then the lunar module can be discarded. In later Apollo missions, it was actually crashed onto the moon so it could be used in seismic studies. The command module then returns to the Earth. The reason that this approach was not favored by NASA at first is that it involved what was seen as a risky maneuver, a lunar orbit rendezvous. However, the enormous savings in mass by only having to land a lightweight lunar module that doesn't even have to be designed to operate in an atmosphere led to this design being chosen. Now, I had always assumed that Wernher von Braun would have favored the direct ascent mission profile because it would involve building a bigger rocket. But it turns out that he was in favor of the Earth orbit rendezvous profile because, among other things, it would have meant building essentially a space station where the rocket could be assembled. And speaking of assembling rockets, let's go ahead and get started on bag 8, and I'll let you know how it goes. Okay, so here is the model with bag 8 completed. It has the support structures on the side of the second stage. I'm guessing that next time we're going to put on the skin of the second stage. So, until then, Godspeed.